Alright guys. Alright guys, so what we're doing today is we're continuing on with linear functions. Most of everything we're doing in this chapter is going to be with linear functions. And you know that a linear function can be written in the form of mx plus b by naming it a linear function. You can also write it in function notation, which f of x equals mx plus b. And we'll get into more of what mx and b are. The notation f of x is another name for y. So y and f of x are the exact same thing. They're interchangeable. So when we start talking about functions, we're going to start using f of x over y. We're going to start using that notation. If f is the function and x is the domain, then f of x represents the output corresponding to the input x. You can use the letters other than f of x. Now, the main reason we do that is because if I said y is equal to 6x plus 4, and y is equal to negative 1/2 x plus 3, plug in the value of x, so plug in 2 for x. Plug in 2 for x. That'd be 1. Which function am I talking about? There's 2 functions up there, aren't there? Yeah, I was telling you to plug 2 into this one. Wait, how'd you know? Would you know which one I'm talking about? Well, no, because they both are in terms of y. They're both the same function, yes? So, to get over this or get around this confusion, instead of using y, we'll talk about f of x, and we can use a different letter and say g of x. Now we can distinguish between these two, because if I say plug through into g of x, we now know which function we're talking about, yes? Because we're talking about the one with g of x. So this is why we use this function notation, because we can talk about more than one function at the same time and still know which function we're talking about. Now, the first thing we're going to do is we're going to evaluate. Evaluate f of x when x is equal to 2 and x is equal to negative 2. So what we're saying for this first one, we want to evaluate this function for when the input is 2. Now the way we would write this is we would say f of 2, because the x value is 2. So everywhere there's an x in the function, we're going to replace it with 2. So we're going to do negative 4 times 2 plus 7. Now at this point here, we can plug it into the calculator, negative 4 times 2 plus 7. And if we do this, we find the value is what? Is negative 4 times 2. Plus 7 is, so f of 2 is negative 1. F of 2 is negative 1. So when the value of x is 2, the y value is negative 1. When the input is 2, the output is negative 1. Any questions on this here? Now let's do the other one, f of negative 2. Well, that'd be negative 4 times negative 2 plus 7. A negative times a negative would be a. And 8 plus 7 is? So f of negative 2 is? Questions on this here? Any questions on anything so far? Are you good with all this here? Yes? No? Maybe? All right, I want you to try these two on your own. Or at least try one of them. And if you, when we look at this here, what are we doing? What are we doing? What do we need to do to evaluate this here? Evaluate f of x equals 2x minus 7 when x is 4 and x is negative 4. So what are we doing with the 4 and negative 4? We are what? putting it in x's spot because we're trying to evaluate f of 4 and f of negative 4. So here for f of 4, we're replacing x with 4. So it'd be 2 times 4 minus 7. Well, 2 times 4 is 8, and 8 minus 7 gives us 1. Now, negative 4 is going to be the same, except this time we're plugging in negative 4, which would be negative 8 minus 7, which is negative. So f of 4 is 1, and f of negative 4 is negative 15. And that's all we need to do for these here. Questions on either one of these here? Let's look at number 2. So we're going to do this 3 times. We're going to do this for negative 4, 0, and 3. We're doing this 3 times. So I'm going to find what? G of 0 and G of 3. And what are we doing? We're replacing x with that value, yes? So for the first one, we're going to have what? Negative, parentheses, negative 4 squared minus 1. Now, when you type this into the calculator, you have to include those parentheses. You have to include those parentheses. Because negative 4 squared is 16, and we have the negative out front. Because I thought 2 would be harder. Or y'all would get more out of doing number 2. Yeah, I skipped number 1. I mean, you can do number 1 in f of negative 4, negative 8 minus 5 would be negative 13. F of 0 would be negative 5, and f of 3 would be 1. So if you wanted those answers to kind of check and see if you did them right, they're up there. Now, when we look at number 2, we plugged in negative 4, and do we agree with negative 17? If you plugged it in yet? So the next one, we'd have negative 0 squared minus 1. And the last one would be negative 3 squared minus 1. Now the next one, we can do negative parentheses 0, close parentheses squared minus 1. Well, negative 0 squared is just 0, yes? So we really just get negative 1. And last but not least, if we do the last one here, I believe we should get negative 10. And that's it. That's all we need to do for these here. Any questions on any of these that we've done so far? For which one? For the second one? For 0?
Do we do this and then that?
Well, these are different. As really we're saying negative 4 squared is going to be negative 4 squared is, and we get negative 16 minus 1.
Oh, okay.
Yeah, this one here would be our negative 0 squared minus 1. Which is 0 minus 1, which is...
Oh.
Yeah, the first one I just chose to bump it down so I would have more room. Yeah, this is all part of the same equation. I just wrote it down on the lower line, so I'd have a little bit more space. Any questions on these here? Are we good with plugging the values in and finding the solution? Yes? Let F of T be the outside temperature in degrees Fahrenheit 2 hours after 6 a.m. Explain the meaning of each statement. So the input value is kind of X, or what goes inside the parentheses with F. Because F of T, so the T here is our time after 6. T is the time after 6 p.m. So if we're saying F of 0, how many hours after 6 a.m. are we talking about? We're talking about how many? 0, yes, because the value of T is what? 0. So what is it saying? F of 0, so 0 hours after 6 a.m. It's what? Because F of T is the temperature, where T is the time after, the number of hours after 6 a.m. Yes? So we're saying F of 0. So we're talking about 0 hours after 6 a.m. And it's going to be 58 degrees Fahrenheit. Any other questions on the first one? Any questions about the first one here? Now what about the second one? What is it telling us? F of 6 is equal to N. So what does the 6 tell me? The hour is what? After 6. So we are 6 hours after 6 a.m. What's another way to say 6 hours after 6 a.m.? It would be what? 12 p.m., yes? So when you say at 12 p.m., it will be what? So what's the temperature? 10 degrees Fahrenheit, because it's telling us that much. Now the first one I could have rewrote instead of 0 hours after 6 a.m. We could have said what? It's just 6 a.m. because that's the time, isn't it? Any questions on this here? So the last one we have is F of 3 is less than F of 9, yes? So F of 3 tells me it's, so we're talking about 9 a.m., yes? And this here would be 9 hours after 6 a.m. And what's 9 hours after 6 a.m.? So it'd be 1,500 hours, or, well, we subtract 12 from it. 15 minus 12 is 3. So we have 9 a.m. and 3 p.m. Now, F of 3 and F of 9 is talking about what? The temperature. Because the T, the number inside, is talking about the time after 6 p.m. The function F of T is talking about the temperature. So it's saying the temperature at 3 is what? The temperature at 9. So it's saying the temperature, so we use these to say these are the two times. Now this is telling us that the temperature at 9 a.m. is less than the temperature at 3 p.m. because f of 3 is less than f of 9. The temperature at 9 p.m. is less than the temperature at 3. Questions on this here? We're ready to look at some more of these here. Let f of t be the temperature outside in degrees Fahrenheit, t hours after 10 a.m. Explain the meaning. So at f of 0, well, how many hours after 10 a.m. are we? None. So it is well, it is 10 a.m. at, I think it'd be better, at 10 a.m. It is what? It is 75 degrees Fahrenheit. Because it's telling us, well, 0 after 10 a.m., well, it's still 10 a.m., so at 10 a.m., it's 75 degrees Fahrenheit. Now, what does the next one tell us? At 1 p.m., because 10 to 11 is 1, 11 to 12 is 2, and then 12 to 1 would be 3 hours. So it's at 1 o'clock, 1 p.m. It is what? Fahrenheit. Because again, what this equals, f of 3 would give us our temperature, and here it is in degrees. Any questions on this here? Now the last one, f of 1 is greater than f of 8. So f of 1 would be 1 hour after 10, which is 11 a.m. 8 hours after would be 18, or 6 p.m. We can kind of count it. 10 to 11 is 1, 11 to 12 is 2, 12 to 1 is 3, 1 to 12, 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 5 to 6. We end up getting 8, because we can count it out. 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. If we count out 8 hours, we get 3. Yes? 6, sorry. Lord. 6 p.m. because it's 8 hours after 10. Have I confused you enough yet? Do we get how we get there? Yes. Now, what is it telling us about the temperature? The temperature at 11 a.m. is 6 p.m. Temperature at 11 a.m. is greater than at 6 p.m. Temperature at 11 a.m. is greater than the temperature at 6 p.m. And we know this because f of 1 is greater than f of 8. Any questions on this here? We good with this here? If we feel comfortable with this here, we'll move on to the next part. Do you have any questions on those 4 examples? So any questions on these 3 here? We feel good with these here? Yes? Well, what would C be? F of 2 equals F of 9. That's telling me the temperatures are the same at those 2 times. Because if they're equal, it means they are the same. Now, example 3 here. F of h of x equals 2/3 x minus 5. What is the value for x for which h of x equals 7? Are we able to find that on the note sheet? Yes? Now, looking at this here, what does it tell us the value of h of x is? It is -7. So this here, h of x is what? So let's replace it. So we're saying that negative 7 is equal to 2/3 x minus 5, and it's wanting us to find the value of x. For what value of x will make this true? Now, one thing we could try to do is plug in values for x and see if it works. But that might take a while and it might not be a whole number. So what we want to do for this here is we want to get x by itself. We want to solve for this value. Bless you. So when we solve for the value of x, the first thing we want to do is we want to get everything else away from x. And what's one of the things with x? Well, we have 2/3 and negative 5. So what's going to be easiest to move first? The 2/3 or the negative 5? The negative 5 is going to be easier to move first, because the opposite of subtraction or the opposite of a negative is addition or positive. So what I would do is I would add 5 to both sides, because negative 5 plus 5 is 0. So what I have on the right side is 2/3 x. Now negative 7 plus 5 is negative 2. Negative 7 plus 5 is negative 2. Any questions on any of this here? Any questions on anything we've done so far? We don't have to. But we're almost done. We still need to get the value of x by itself. Well, what is with x? 2/3, yes? I can't minus it because these two here are being multiplied. So the opposite of multiplication is division. I can divide both sides by 2/3. Well, these here will cancel. On this side here, we're left with x. And negative 2 divided by 2/3 is, well, plug it in. Plug it into your calculator, see what you get. Do we all agree? With negative 3? Do you all agree with that there? Yes? Now, if you're not sure that you got the right answer, what we could do is we could plug it in. So I could take the original statement, 2/3 x minus 5. And I'm going to plug in negative 3. We can type that into the calculator. You can do 2/3 times negative 3 minus 5, yes? You can plug that into the calculator. Plug it in and see what you get. Do y'all get negative 7? What did it tell us that h of x equaled for this problem? Negative 7, that's what we got, didn't we? So that's all we need to do for this here. Any questions on this here? For g of x equals 1/3 x minus 2, find the value of x for which g of x is equal to negative 4. So again, we're going to do the same thing that we did on the last one. We're going to replace g of x with negative 4. So negative 4 is equal to 1/3 x minus 2. Now again, to find the value of x, we need to get x by itself. So what do we need to do first to get x by itself? We need to add 2 to both sides. Because that's going to be the easiest way to get x by itself. Well, negative 2 plus 2 will... Well, negative 4 plus 2 is negative 2. Because the negative 4 is bigger, so negative 4 plus 2 will give us negative 2. Now, what do we need to do next? So we can divide both sides by 1/3, and that's fine. Because if I divide both sides by 1/3, well, 1/3 and 1/3 will simplify, leaving me with x. And what is -2 divided by 1/3? Now, there's actually another way to do this from this point here. What I could do is I can multiply both sides by 3. Now, this seems like a weird step, but let's look at this here. 3 times -2 is, isn't that what we got when we divided both sides by 1/3? We got -6 on one side. Well, 3 times 1/3 would be 3 over 3, yes? Well, what is 3 divided by 3? We get this here, yes? Now, when we have fractions, we can divide by it. Like here, we can divide both sides by 1/3, and that would work. Or we can multiply by its reciprocal, the flip of it. And it will work. So if we go back one here, erase this. Now at this point here, we had -2 is equal to 2/3 x, yes? So what's the reciprocal of 2/3? What's the flip of 2/3 if we flipped it? We would flip it and it becomes 3/2, yes? So on this one side, well, we'd have -6 over 2, because 3 times 2 is -6, yes? And over here, 3 times 2 is 6. 2 times 3 is 6. Well, -6 divided by 2 is -3 like we got, yes? 6 divided by 6 is 1. So we get the same thing, yes? So when we hit a fraction and we're trying to divide, we can either divide the fraction or multiply by its reciprocal, the flip. Either way will work. Questions on this here? Any questions on anything we've done so far? Let's look at another one. Let's look at number 4. Now, number 4 is telling us f of x is what? 21. So we'll set 6x plus 9 equal to. Now we need to solve for the value of x. So what would we need to do first to solve this? We would need to what? We would need to subtract 9 from both sides. And when we subtract 9 from both sides, well, 9 minus 9 is 0, so I get 6x is equal to 21 minus 9 is 12. You can do that in the calculator. 21 minus 9. Go on and do it. See if, make sure I got it right. Did y'all get 12? And then what do we do next? We would divide both sides by 6. And so we get x is equal to 2. Any other questions on this here? Any questions on anything we've done so far? Okay, that brings us to the last thing that we're going to do here. This brings us to the last thing we're going to cover today. That is graphing a linear function in function notation. Now, the way that we're going to graph this, and y'all have graphed points, yes? Y'all have graphed points, x, y. So what we're going to do, to graph it, to graph any line, I need 2 points. To graph any equation of a line, I need 2 points. So looking at this number line, someone give me an x value. Doesn't matter which. Okay. I would go lower than 6. Let's. I'm just going to do 1 and 2. Because otherwise it might get a little big. So we can say near the x-axis, it really doesn't matter. We could use 6 and 4. Those would work fine, but they might be a little big for this graph. Does that make sense? So we're going to plug them in. So f of 1 would be what? 2 times 1 plus 5, yes? Well, 2 times 1 is? Plus 5 is 7. So at 1, when x is 1, y is 7 up here, yes? So on the homework, you will have a little bit bigger graph than this, so it'll still work. We have 1 and 7. Now at 2, at f of 2, what are we going to do? We'll do the exact same thing, yes? So we'll have 2 times 2 plus 5. Well, what is 2 times 2? And 4 plus 5 is 9. So here we'll have 2, 9, which is even higher up, yes? It's even higher up on this. She can come in a little bit. We can do this here. Now this here unfortunately didn't work well for our graph. So we could try different values. So we could say f of 0. Well, that would be 2 times 0 plus 5, yes? Well, 2 times 0 is what? Which just gives us, so I could say 0, 5. And we can have a line. Now the graphing calculator, or the graph on the computer, once you have 2 points, it'll make the line. Because as a line, you do plot those 2 points, and it'll create the line for you. Because a line through any 2 points. We have 2 points, don't we? So we can make a line. Now, let's use, so we have 5, 0. I'm going to use -1. F of -1, so we can see it a little bit better. Well, that'd be 2 times -1 plus 5, yes? Because we're plugging it in to get the point. Well, 2 times -1 would be negative plus 5 is, so -1, 3. Now, through any 2 points, we can draw a straight line. So if I was doing this by hand, I would get a straight edge out, just something with a straight edge, like a ruler or whatnot, and line it up so that I can draw a straight line. So I'd set it up so those 2 points lined up, and we draw a straight line. Let's go forward. Let me actually get a ruler. Let's see how well I can operate this thing. Come on. Because what we'd want to do is bring it over here. Okay, it's not going to let me do it. Oh, there we go. So I can bring it over here and try to straighten that up along those points. Almost. Like this here. And that's close enough for our all intents and purposes. And now I can control it. But then I would try to use it to draw a straight line. Yeah, I don't like using this thing. Yeah, that's way too much. But we can do that to draw a straight line. Now the big idea is math. As soon as you plot, because it'll say line, as soon as you put 2 points, it'll draw a straight line for you. Questions on this here? Now for a test, I want you to have those 2 points named and located on the chart. If the line's not exactly a straight line, but it hits through those 2 points, we're good. Now looking at this here, we're going to do another one. I need 2 points.
Wait, on these ones, it can be any number?
Yes. Now, as we saw with the first one, it might be helpful if the point's going to stay in here. I will keep a 10 to 10 range. So I would stay closer to the center, hopefully, because it might work a little bit better than if we hit the edges. Because as we saw with the last one, even when we went with 2, it was way off the chart, wasn't it? Well, yes. So we could try, say, 0 and 1. So what would f of 0 be? It would be 3 minus, which would be? So we have 1 point at 0, 3. When x is 0, y is 3. Yes? Now let's find the other one at f of 1. Well, this would be 3 minus 1. So 1, 2. Anytime we get 2 points, we can draw a straight line through it. Questions on this here? Now, if we wanted to, we can grab more than just these 2 points. We can grab as many as we want going left and right, but we only need 2 to draw a straight line. Questions on this here? Do we need to see another example one of these? We feel comfortable drawing this straight line? We all drawn straight lines before? We've graphed this? Awesome. And that's really all we're going to talk about with this here. I mean, we could talk about fractions in this here. Now this is a stretch, but what would we call negative 3/4? Do you all know the name of it? 75. Or it actually has a name. It's part of a line. If you don't, that's fine. Have you guys heard of a word called slope? Because what is this? This is in the form of y equals mx plus b, where m is the slope and b is the y-intercept. And we'll go into more of this later on, but that is going to come up later.